Hello everyone, in today's topic we are going to talk about tree diagrams and we are still in probability. What are tree diagrams? Tree diagrams can be used to help solve problems involving both dependent and independent events. The following situation can be represented by a tree diagram. Peter has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag and notes the color before replacing it. He then chooses a second cube at random, record the information in a tree diagram. So the word replacing is very important in this kind of problem. So for the first choice, we have red and blue. And there are 3 reds, so 3 over 10, and there are 7 blue, so 7 over 10. And for the second choice, because of the word replacing it, we still have red and then blue, red and blue. So from here, since we choose red already and then Peter replace it, we still have 3 over 10 chance of getting it. And then for the blue, because we chose red, so it is still 7 over 10. And then in here is still 3 over 10 and is still 7 over 10 because of the word replacing. So from here, we are going to multiply for the probability of red and red. So we have 9 over 100 and then multiplying the probability of red and blue, which is equal to 21 over 100. And then multiplying the probability of blue and red, which is equal to 21 over 100. And then the probability of getting blue and blue, it is equal to 49 over 100. So that is how we represent the tree diagram for problem like there is a replacement. So the word replacing is really very important. Now let us have the characteristics of a tree diagram. So ends of first and second level branches show the different outcomes. Then the probabilities of each event are shown along the arm of each branch and they sum up to 1. So if we are going to sum it up, it is equal to 1. The probabilities are multiplied along each arm. So let us have question number 1. Rebecca has 9 colored beads in a bag. 4 of the beads are black and the rest are green. She removes a bead at random from the bag and notes the color before replacing it. She then chooses a second bead. Draw a diagram showing all possible outcomes. Calculate the probability that Rebecca chooses 2 green beads and then Rebecca chooses a black followed by a green bead. The first thing that we should do here is to make our tree diagram. So once we choose black for the first choice, we still have 4 over 9 probability of getting black for the second choice because of the word replacing. So if the word replacing appears in a problem, no need to subtract, okay, from your first choice. So why do we have 5 green? Because it says there in the second sentence, 4 of the beads are black, so the rest are green. So 9 minus 5 or 9 minus 4 equals 5. So we have 5 green. So that is how we have 5 over 9 in the second choice if we choose green for the first choice because the word replacing it, okay? So in here, we have the probability of getting black and black, which is equal to 16 over 81, and the probability of getting black and green, it is equal to 20 over 81, and the probability of getting green and black equals 20 over 81, and the probability of getting green and green is 25 over 81. Going back to the problem, so what is the probability that Rebecca chooses 2 greens? Just take a look at green and green. So the answer for the first question is 25 over 81. And for the second one, a black followed by a green bead, it is equal to P black and green. So looking at it, it is equal to 20 over 81. Now let us have question number 2. Peter tosses 2 coins. Draw a tree diagram to show all possible outcomes. Use your tree diagram to find the probability of getting 2 heads and a head or a tail in any order. So from here, making our tree diagram. So for the first coin, we have the probability of getting head, 1/2, and getting a tail is also 1/2. And for the second choice, of course, second coin, it is also 1/2 for the head and 1/2 for the tail, as well as the 1/2 for the head and 1/2 for the tail. So the probability of getting head and head, we have 1/4, and the probability of getting head and tail is 1/4, and the probability of getting tail and head is 1/4, as well as getting tail and tail, it is 1/4. So in getting 2 heads, we have 1/4. So the probability of getting 2 heads equals 1/4, and the probability of getting head and a tail, or the other way around, a tail and a head, it is 1/4 plus 1/4, it is equal to 1/2. So let us have question number 3. Peter and Becky run a race and play a tennis match. The probability that Peter wins the race is 0.4. So for the race, the probability of Peter is 0.4. So for Becky to win the race, it is 1 minus 0.4. Okay, and then the probability that Becky wins the tennis is 0.3. So the probability that Peter wins tennis is 1 minus 0.7. Complete the tree diagram below. Use your tree diagram to calculate the probability that Peter wins both events. The probability that Becky loses the race but wins at tennis. So from here, the probability that Becky wins the race is 1 minus 0.4. So we have 0.6 over there. And then the probability of Peter wins tennis, it is 1 minus 0.3. So we have 0.3 over there. Okay? It's a matter of subtracting it from 1. So from here, the probability that Peter wins race and Peter wins tennis is 0.4 times 0.3, which is equal to 0.12. And the probability that Peter wins race and Becky wins tennis is 0.4 times 0.7 equals 0.28. And then the probability that Becky wins the race and Peter wins tennis equal to 0.6 times 0.3, which is equal to 0.18. And the probability that Becky wins race and Becky wins tennis, it is equal to 0.42. So from here, the probability that Peter win the race and tennis, we have 0.12, while the probability of Becky losing race and then wins tennis is equal to 0.28. Now let us have another one. For the dependent events, so the following situation can be represented by a tree diagram. Peter has 10 colored cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag and notes the color but does not replace it. So we have the phrase does not replace it. So from here, later on, we are going to subtract, okay, for the second choice. He then chooses a second cube at random. Record the information in a diagram, in a tree diagram. So we have this one, the first choice, red, blue. So we have, for the red, it is 3 over 10 because there are 3 red. Okay, and then for blue, we have 7 over 10 because it says there in the second sentence, 7 are blue. For the second choice, since we already choose red, for the first choice, so there's no replacement, does not replace, okay? So we are going to subtract. So we have 2 over 9 to get another red. And then for the blue, of course, it is 7 over 9. And for getting red for the second choice, we have 3 over 9. And for getting blue for the second choice, so 7 minus 1, we have 6 over 9. Okay? So the phrase do not or does not replace means something. You need to subtract it in your second choice, or subtract 1 in your second choice. Okay? So from here, we are going to multiply the probability of red and red, which is equal to 6 over 90. And the probability of red and blue, it is equal to 21 over 90. And the probability of getting blue and red, it is equal to 21 over 90. And the probability of getting blue and blue, it is 42 over 90. So that is how we represent the situation. Now let us have question 4. Rebecca has 9 colored beads in a bag. 4 of the beads are black and the rest are green. She removes a bead at random from the bag and does not replace it. She then chooses a second bead. Draw a tree diagram showing all possible outcomes. Calculate the probability that Rebecca chooses 2 green beads and a black followed by a green. So from here, making our tree diagram already. So if you are going to choose black for the first choice, for the second choice, you need to subtract. So 4 minus 1, so we have 3 over 8, okay? If you choose for the first choice green, and then you choose again for the second choice green, so you need to subtract 5 minus 1, it is 4 over 8, okay? Because the phrase does not replace means something, okay? You need to subtract from your first choice to your second choice. So the probability of getting black and black, it is equal to 12 over 72. And the probability of getting black and green, it is equal to 20 over 72. And the probability of getting green and black, it is 20 over 72. And the probability of getting green and green, it is 20 over 72. Going back to the question, so the probability that Rebecca chooses 2 green beads. So take a look at the green and green. So the answer for that one is 20 over 72. While a black followed by a green, take a look at P black and green. It is equal to 20 over 72. Now let us have question 5. So Lucy has a 5 bags of 30 chocolates. 18 are milk chocolate and the rest are dark chocolate. She takes a chocolate at random from the bags and eats it. She then chooses a second. So draw a tree diagram to show all the possible outcomes. Then calculate the probability that Lucy chooses 2 milk chocolates and a dark chocolate followed by a milk chocolate. So in here, if you eat, you do not replace at all, okay? So we have, if she chooses milk on the first pick, she will gonna have the probability of getting milk for the second pick 17 over 29 because 18 minus 1, okay? And if Lucy already picked dark chocolate on the first pick, so for the second one, 12 minus 1, the probability of getting dark chocolate in the second pick is 11 over 29. So once you eat, of course, you cannot replace it, okay? So the probability of getting milk and milk, it is 306 over 870. And the probability of getting milk and dark chocolate is 216 over 870. And the probability of getting dark and milk is 216 over 870. And the probability of getting dark and dark is 132 over 870. So going back to the problem, calculate the probability that Lucy chooses 2 milk chocolates. So It is equal to 306 over 870. And the probability that Lucy chooses a dark chocolate followed by a milk chocolate, it is 216 over 870.